Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 1356 sort integer by the number of 1 bits. So you are given an array of integers here and our task is to count how many 1s each element or each number has in its binary representation. So very first, we should sort the array first by the number of 1 bits in the ascending order, and if the two numbers have the same number of 1 bits, we should sort them in numerically, right, in the number format, uh, in the number sorting, right. So as you can see, we have given the array that is in that is we have is in the input we have given array 0 1 2 3 4 5 6 7 8, right, and we have something the output like this. So we'll try to understand in this video to see what we have to do. So let's understand in detail. Very first, we have given the array, and this array is array of integers, and this array of integers we have given, and we have to count how many 1s each number has in its binary representation. So we should sort the array first by the number of 1 bits in ascending order, and if two numbers have the same number of 1 bits, so we have to sort them in numerically, right, so as we have discussed. So you know that each number can be represented in binary, right, with respect to 8421 concept, or if we want to represent the number into 4 bits, right. Let's suppose 00 can be represented in 0 can be represented as 000 4 times as a 0 bits. If you talk about, there is how many 1s is there, there is only 0 1s is there. If we'll talk about 1, we can say 001. It can be represented in like this. So 1s available is 1 time. Similarly, 2 is having 2 time not one time 1s, and for 3 we can represent 0 0 1 1. There is 2 ones are there. If we represent 4 into binary, it will be 0 1 0 0, and it will be 1 ones. Then we have 5. If we'll represent 5 into integer, 1 0 2 ones will be there. Similarly, if we'll convert 6 into the binary representation, it will be 0 1 1 0. It will be 2 ones will be there. And similarly, if we'll convert into 7, it will also be 0 1 1 1, means 3 ones will be there. Then we have 8. If we'll convert 8 into the binary representation, it will be 1 0 0 0. There will be 1 ones. Means we have counted how many 1s each number has in its binary representation. This is the first thing that we need to do. Means we have to count, or we have to convert the numbers, each numbers in binary representation, and we have to count how many 1s each number has, like this. Okay, the second thing is that we have to sort the number, or we have to group the number for the all the 1s based on the 1s. If two number have the same number of 1 bits, we will sort them numerically. Basically, we have to, based on the 1s, right, we have to group them in each group we have to form. Let's suppose for zeros, how many ones is there? Ones is there. For 2, how many 2s are together? So 2 ones, second group will be for the 2s. Then similarly will be have, means for the ones, these are the ones we have. So 1 2 4 and 8 will be the another group where we have 1 ones will be have. Then we have what are the things are there? 3 5. So let's suppose the third group will be here is 0 1 1 1. Yeah, 7 will be the three ones will be there, right? And so we have formed, these will be the group in the ascending order, means where we have convert into the binary, and then we have convert into each group, right? So if we'll join it back, right, so it will give you the output. As you can see, the output contains 0, 1, 2, 4, 8, right? And then it comes 3. So very first the zero count, zeros ones is 0 ones, then we 1, 2, 4, 8 are ones, right? Then okay, so we have left, we have not written this one. 3, 5, 6 are the two ones group, right? So we have to take two ones group also. 3, 5, 6 are the two ones group, and 7 will be the three ones group, right? So each group, if you represent, so 0 is from the zero ones, and 1, 2, 4, 8 is one is ones, and 3 is 2, 3, 5, 6 is three ones and two ones, and 7 is three ones. So if you see, this is the output exactly matching, means very first we have to convert it into binary, then we have to group with respect to the one is, right? And you have to do the one is only because we have counted the number of one is in each number, and we have sorted the array first by the number of one is in ascending order. If the two numbers have the same number of 1 bits, means we have also sorted them in numerically, right? So this is what we have to implement, right? And it's very important to understand the question and how to implement, right? So what do you think that the approach is mathematically, or it's based on the bit manipulation, right? It's very important to understand, because if you sort the number by oneness, right, it means we have the group, each number group, right? And we can convert easily, right? Now understand how we will implement, what will be the our approach, right, that we will solve this problem. The very first thing is that we will take integer. It's not a big trick, so we have to, the intuition is to, this is the intuition where it's not a big bit manipulation or bit tricks. It's a completely mathematically sorting, right? So it's a sorting technique, we can say, where we have to use the comparator logic, and then we have to implement it, right? So in the Java, the concept of comparator will become where we can do the sorting. So it's a sorting. Let's suppose, for example, if we want to sort the students, right, what we need to do, right? If there is a lot of students are there, so very first we want to sort the student first by their marks, right? And if the student having, let's suppose, two students have the same marks, right? If the student marks are equal, in that case what we need to do, we need to do something, right? What is something we need to do? Think. So if the students are sorted by the first by the marks, if the equal marks are there, then we will sort with the roll number, correct? Similarly, we have here the concept that we first do the bit counts, and once we'll do the bit counts, means we have to check that if bit counts are equal, similar to the same concept, right? If the bit counts are the same, it means we have to sort by the numbers, okay? Numbers in the ascending order, based on the ascending order, we have to convert it, okay? And the sorting and these thing both can be done only by the multi-level sorting, correct? We know that the this problem is not based on the bit manipulation. There is a concept in the Java is comparator to sort the element if there is multiple multi-level rules are there. right? Multi rules are there. So those rules can be customized in the multi-level sorting. First we'll find the bit count, and then we'll do this concept. So let me clean this so we can understand further. Okay, so the thing is, let's understand how we compare two values, right? We have a and b, right? And if we want to compare the two value, right, it's not so important to understand the normal sort. So because this is not the normal sort, so we should understand the intuition how we are going to solve this problem. We'll count a, we'll create a count a from, we will get the bit counts, means number of bits we want to find. The very first key is bit count. Once we will get the bit count, right, then we'll check if the bit counts are equal, right? Once the bit counts are equal, it means we can make a condition and we'll say, okay, if count A not equal to count B, means we will return something. What is something there? So count A minus count B, we will get some bit count of A and B numbers, right? A and B are the integer numbers. So we'll get the bit counts. It means we will return count A minus count B. Okay. Once this is done, we'll say, let's suppose if the count is not equal, right? It means we will go in the else condition. In the else condition, we will normally check the ascending order of the number, means a minus b will do, it will return. If the let's suppose if a and b having marks are not equal, right, then we'll just do the minus and this comparator will work. Otherwise a minus b will do. So if it is equal, we have to do the same thing. Now if you want to compare 3 and 4, let's suppose 3 and 4, it means we know that 3 contains in the number of bits is 1 1, means there will be 2 ones are there. For the 4, we know that if we'll convert into this binary representation 0 1 0 0, there will be 1 ones. It means the 1 ones are smaller than the 2 ones, right? And that is why the concept is that it's a efficiently it will count one bits, because we have given the number of 1s or number of 2s we have already counted, right? Once we have counted these numbers, so it is easy to do based on the uh, ascending orders, right? It is easy. Once we will convert this 1s, right, let's try to understand the code first so you will understand easily. The very first we have to convert the elements, integer elements, into the integer object, because both are not equal, right? We have to convert the integer into integer array, because the primitive arrays can't use the custom comparator, because inbuilt function comparator is there and we want to use that, because integer.bitCount method is there in the integer, not the integer value, integer. So primitives array can't use the custom comparator, so let's convert into integer array. So integer is a object, so we'll say integer array and we'll convert into the array. So this is arrays dot string we will use. Very first we will convert the array, given array, into the string. So once you converted the given a primitive array into the stream object, you can use the stream functionality, the box. So we will first do the box method, we'll call, and then we'll convert into to array. When we are converting to two array, we have to say that it should be integer array, and we have to form the new. So you can use this operator and you will just write new. Okay, so we are initializing integer array here, right, with respect to the integer here. Now we will use the comparator concept that we have understand. We'll do the arrays dot sort method here, and over the temp object, right, that we have converted into integer array, we will try to do here, means we will implement the comparator. So to convert into the comparator, to use the comparator concept, you need to use arrays dot sort, and we'll pass the object temp, because this object temp contains all the details, right? All the details means all the array elements into the integer arrays, right? So we'll pass this a and b, and we know that we will convert this a and b into count, right? Because we have to first call the integer dot bit count, because this integer dot bit count contains integer bit counts. The bit counts contains the method in integer, so it is efficiently count number of bits, set bits we can say, by using the optimized CPU instruction, and we can count the number of ones easily. So we'll do integer of bit count, and we'll provide a, and similarly we'll provide integer dot bit count for the b. Okay, so count b, count a, we will find it, and similarly we have to write bit count, and we will pass b here, bit count b will pass. Then we'll say if count a not equal to count b, it means we will return, it means the both count are not same. If both count are not same, it means what, we have to do count a minus count b, and we'll return the concept, we will return the minus, right? So let's return count a minus count b, count a minus count b. If both are not equal, if the counts are not equal, we have to return, else we will return a minus b, because the bit counts are not same. If bit counts are not same, we'll return a minus b, just return in the ascending order. Okay guys, like this we will implement the comparator, means it will do the sorting, multi-level sorting, it will happen. In other cases, you will return arrays.stream, because we have to return it back into integer primitive arrays, because this is integer objects. So we have to convert into the primitive arrays, because we have converted it into the primitive arrays to integer object. So because we was not able to use the custom operator, because this is custom operator, we have used the custom operator to do the sorting. So we will first will write this, we will convert it into a string, then we will do map to integer, we'll do the integer will be get converted into the int value, and we'll call the int value here, and then we'll call the to array. So to array will convert it back into the primitive array, right, from the object. And let's try to run this, so you will understand that this is easy to implement, right? So this is the array we have, right? So this array we have converted into the primitive arrays, because we can't use the custom operator, guys, right? So we have to convert the input array, then we will write the custom comparator, right? So this is multi-level sorting. Basically we have to convert into integer object, right? Because we want to use the custom operator and the bit count function, right? Two things we want to. So though if you write the integer, it will not work. So integer object you will write, that it will work. Okay. Then we are converting back, right? So this bit count is also available in the integer, right? So we have converted into this one. Now we are converting back the, because this is the return type we have given, so we have to convert it back into the primitive arrays, and so it will work perfectly. Due to the comparator, right, it will take n log n because we have used the custom comparator, and we are storing into, we are converting into integer object, so it will take O of n, and for the comparator it will take O of n log n. Okay, I hope you understand this. Thank you guys, thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.